So welcome everybody to this webinar on the data model, the heart of a digital twin. So we've got a lot to get through today because the data model is a big topic. I'm going to cover some of it today, and we'll probably do another webinar on this in the near future. So what I want to talk about today is what the data model is, how a user can interact with it, and then also a brief example of what a computer sees. We're going to look at an example of a UI component that can use the data model. Then we're going to do a demo of creating a very simple model, just a well and a well bore. I'm going to talk about something called the class library, which is a really important feature of making data models. And our data model, the Eigen Ingenuity data model, allows you to either use a class library or not. If we have time, I'll talk about information maturity and how you can go step by step to create a model on very immature information and then refine it over time. And lastly, we'll have questions. If anyone has any questions, then please put them in the chat as we go and we'll get to them at the end. Okay, so what is the data model? In its simplest form, it's a map of your data and information and how it's related. It's a digital map, a bit like a normal paper map that shows you how you can get from one place to another and the connections between things. This is an example of a piece of equipment and all the things related to it. So if we were to start at the top, you can see that it has some classifications. The fact that it is a transmitter, in this case, it's a pressure safety transmitter. And then going round clockwise, we can see it's part of a system. It's related to a system. It's physically located in an area and also a sub area. It relates to or is part of a performance standard. So it has certain criteria that it needs to, or certain performance requirements that it needs to meet. It's part of a barrier element, being a safety transmitter. It's providing some protective functions, so it's linked to some barrier elements. It's got documents related to it. So these might be calibration certificates or P&IDs. Then going further around, there's actually some resource numbers and spare part numbers. Then we've got equipment that it's related to. So this safety transmitter, it may also have other instruments that maybe it's a 2 out of 3 voting or something. Then at the top, at about 10 o'clock, as we look at it, we've got the fact that it's part of a blowdown segment. So this is a blowdown segment is a section of pipe work, and it will have a valve related to it and also a pressure transmitter. So that's modeled here as well. And finally, going to the top, we've got the fact that it's linked to some time series data. In this case, it's pi tags. So we have some pointers to the data in those systems as well. So how a user might look at this information is through the Eigen Ingenuity's common menu. So this is a standard component that gives you access to all the related information. And I have an example of that here. Here I've just got a dashboard, and if I click on this separator, this brings up a common menu, and you can see here some status information, then some properties. So this is all coming from the data model. Then we've got measurements, that this would be the related time series. If it's got any alerts, if it's got related documents, and these are links to the documents. They're not, the documents aren't stored in the data model. They could be if you wanted, but we prefer to link to them. And then we've got related assets. So this would be things like the fact that it's related to another piece of equipment, an LP separator. It has a parent, it's part of the platform, it's in a system. The oil flows from the HP production manifold. And we've got a link to any maintenance in this case as well. Okay, so this is where, just to tie that together, we've got the things like the measurements tab, pulls the data for where you have relationships to, has measurements within the data model. So if you look, if I just go back to the previous slide, you can see here that the relationships are actually named between the objects. So here we have has historian tag. The pressure safety transmitter has a historian tag, and that links to a pi tag. And the same for the other relationships. We've got things like part of barrier element. And that's how the data model is able to, the common menu is able to pick out the things to put on the different tabs. So going around, you've got the fact that there's the other related things that it's part of. You've got the related documents are pulled out into a special documents tab, and the related assets, again, we've got the related equipment there on the bottom left. Now, if you were using this in a program, you would actually use the API and you'd get a JSON response. So this is how the data model would look to a computer that was talking to it. You would request, there's a number of calls you could make, and one of them might be, give me all related information to this object, and you'd get a JSON response, something like this, and that can then be used in a Python program. So here's an example of how an object in the model can be used to drive a UI, a user interface component. So for this example, we're going to use our component called the object template. This allows you to put a control on a page that points to a certain type of object within the data model. You pick that object and you'll see in a minute that you can select from the class or the property. And then the properties and related things on that object are used to drive the content of the page. So here's a short video showing you. First of all, we're going to show that this is an example well. In fact, it's a well bore, and this has all this related stuff on it. A lot of these are time series data. They're things measuring properties on the well bore, for example, the wellhead pressure. And we're going to use some of these properties then to drive displays. So here we've got a basic page, we've got the object template, then we've got two components, a KPI and a trend. And this first little video is going to show you configuring the object template. So here we go into settings and we're going to choose the object class. And here we've chosen wellbore. And then this lets you select the property of that object to list in the dropdown. We're choosing code, could also have chosen name. Something human readable is always best. And here now you can see, here's a list of the wellbores now in the dropdown. So now jumping ahead, I've already configured the KPI component. And in this little example, we're going to now configure the trend component. So here, when we go to configure the data sources, we use the object template tab, and this exposes those properties, the related information from the data model. So here we're picking a number of them, and the last one that we'll get is the wellhead pressure that we looked at briefly in the model in Neo4j. There we are, there's the wellhead pressure. So we'll add those to our trend. So it's using the pointers in the data model to go and get that information now from, actually this is IP21 in this case. But the beauty is for the user, they don't need to know how to use that source system. It's all handled by the interface and the data model. So now we've made our chart. There we go. So now in the next example, we can see that when we change the selection in the list, we get to update all the content on the page. And now we'll choose a different wellbore and it will update everything then on the page. Simple. So that's the beauty of how the data model can hold the pointers, and then the UI components just need to know the object to look at, and the data model gives them and all that related information. One other thing to show on the this object template component, the fact that you can reveal all the details. It's another way for the user to interact with information from the data model. Here's all those related time series, and here's the other properties. And here's the common menu then for that well, which gives you access, just like in any other way, to the information in the model. So how do we build a model like that? So what we're going to do is go through building a simple model of a well and a wellbore. I'm going to talk about how you create the objects and the class library. We'll go into more detail on the class library at the end as well. We're going to talk about the relating objects and linking to the information in other systems. So the model we're going to create is going to be a wellbore with one related well object, two pieces of instrumentation, and one document linked to it. This is the model we're going to end up with. So we've got the slots, the wellbore I'm just going to call slot 01 is in the middle. We've got the two time series tags. Then we've got a document. The time series and the document are in blue, and then the well at the bottom is in red. There's two other objects in green and yellow that are created automatically by our build systems that are used by our Eigen code for tracking things like versions and managing the class hierarchy. Then you can see here that the objects that I'm going to create have bidirectional relationships. They've got, from the slot, we can see we have has measurement, and then going the other way, the measurement, the time series data measures, in this case, choke position for the well bore. So if I show you that in real life, oh, it's on the web browser. Here we go. So here is the well model currently. I have it running, but just to show you that this is live, but I'm going to rebuild it later. I've renamed the well BO1 so that when we rebuild the model from scratch, you'll see that that reverts back to being called AO1. But there's the model as it stands, and we're going to rebuild this, and I'll show you how it's made. So the first thing we need to do is to make a spreadsheet. Well, we can start with a spreadsheet. If you know how to make the build files themselves, you could go straight to them. But I find the easiest way is to start with a spreadsheet, and then we just make this table of the key object that we're looking to build, in this case the slot, and then we relate the other objects to it across as other columns. So here I've got the slot O1 is going to be related to a well, and I've called it, the property on the relationship will be well. The class of the object is a well. The relationship will be called has well, and the return relationship will be called has well bore. Then we do the same with the two the time series tags. So we're going to make a wellhead pressure and a choke. We're going to call these measurement sources. So these node classes are called measurement source. Then we've got a relationship name has measurement going from the well bore to the time series object, the measurement source. And then coming back, we've got measures wellhead pressure of and measures choke position of. And then finally, we've got a document. Now, using some of our Eigen build scripts, these are converted into simple semicolon or comma separated files that are used by the build system. And this is what they look like. You've got a header row. So in its simplest form, to create a node, you just need to list its facility, its ID, and its class, and whether it's active or not. Now, when you're building a model, it's very unlikely you'll build something that's not active. So here we have the header row, and then we just list the node. So we've got slot O1, it's a well bore class, and of course it's active. Then we've got the well, it's an all production well. Then we've got the two measurement source tags. We've got the demo, the pressure instrument and the choke position, and then we've got the document. These are related together then in a relationships file. So first of all, you build the nodes, and then you go through and you say how they're related. So again, here the first row is a header row, but then we define each of the relationships. So slot O1 has well AO1, and the property of the relationship is well. And you can see the reverse relationship is well AO1 has well bore slot O1, and that gives us the relationships in both directions. So the way the build process works is it takes all these input files that we've made. So here I've got the list of the folder that's going to be used to make this. We've got a nodes and a relationships file. So the basic files you've just seen are the demo basic well, relationships and nodes. But I've also got some other files that list additional properties of each of those nodes. So for some of those nodes, and that lets me add additional things, like for the document, I could add a URL for it. We have an asset model build system that runs in Docker. So what you're going to see is this system just running in Docker basically, and I'll tell it to do something using the command line. It will pull in those CSV files, and then it will go and build that model in Neo4j, and we'll see the output in the web browser. So if I go across here, then here's my build system, and I'm just going to run a single command which uses Docker, and it's going to say build. It's going to run a build file, a YAML file that lists the files that the build system has to use to create the model, and it runs very quickly. There we are, it's starting to build the container. It goes through, it's building all the nodes, and it's done. So we can see here model verification succeeded right at the bottom, and it's closed the connection. So now if we go back to our web browser, and if I reload this page, then there we are, let's reload it, put it back to full screen. If I open up my wellbore now, and I see the related nodes, you see my well's gone back to being A01. So this is a clean model, it's a new model that's just been built from those files that we had. And if we go into something, let's look at one of the objects and just see some of the additional information that came in from those other properties files. So if I look at the well, for example, we've got some additional properties here that it was from the Ringhorn Jurassic Formation. It's got a type, a perforation type here. There's various other things like the well legal name here that have been added by adding an additional file with more properties for that object class. And also the document here, we created the node ID with just the document name, but there's a lot more properties. There's the URL for it. So here's there's a URL and an alternative URL for it. So if I were to take this URL, and this is just to show that it's a pointer to the data, that we're not storing the data in the data model. If I put that in the address bar, oh, there we go. There's my document downloaded from the source. It's our demo system, but it's not that I didn't load that document into the model as part of this. I just loaded the pointer to that document into the model. So that's how we build the data model. So let's go back then and talk a little bit about the class library. And again, if you've got any questions from this, please do put them in the chat, and we will get to them at the end, because I think it's a big subject. So the class library, this gives you the option to add rigor to your model. So an object's class defines the properties and relationships it has. An object can also have multiple classes, and this is something that the Eigen data model can do that is so powerful, because in practice objects are often more than one thing. And a classic example is a person. A person has lots of different roles, and the information you want to know about that person can vary depending on the role they're in. So for example, if they're an employee, then you want to know their employee number and their payroll number and the date they started. If they're a customer, it's the same person, don't forget, but now they're a customer in a shop. Well, you want to know how many times this person visits, what's their average spend, again, what's their socioeconomic class, probably their address, things like that. Or you might, if they're a parent, you want to know who their children are or who they're married to. So depending on the role that you're looking at the object for, you want to know different things about it. So here's an example of a class file. The class file lists the properties and the relationships that the object can take part in when it has that class. So here we've got a simple example where you have a superclass. So in this case, I forget, but I think we're looking at a measure. This is a wellbore class we're looking at. It inherits properties from the asset object class, that's its superclass, and it then adds a bunch of properties, one being the slot. Within the class file, we then define the Java class that can be used to interact with this object. Now, you could just query the data model directly in Neo4j and get all this information about it. But by also linking the object to a code library, you can also automate certain things about that object. For example, the automatic calculation of other properties. Or for a wellbore, you might add in something like automated calculation of drawdown. if you know the downhole pressure and the top hole pressure, you could add virtual properties, if you like, that could be queried because it's based on a standard template of things. Then we've got the data type. So is it a string? Is it a date? What else is it? And one of the interesting ones at the end is the document class, in that we have an Eigen Ingenuity document link. And that tells us how to handle URLs, things. Now, you don't need to use the class file to build the data model. The model will still build without the classes, and you can still use it. But what the classes let you do is add a level of rigor into your model when it's available. And so that brings me on to this idea of information maturity that I mentioned at the start. So one of the challenges is when you build a data model, you don't have all the information to start with. So what we can do is just build it. The simplest thing you need to build a node is an ID for it. So in this case, we called ours AO1. But as time goes on, you may then get more information about such object. So in this example, I've got this is actually a barrier model, and this is modeling a major accident hazard scenario. And here we've got a bunch of instrumentation connected to it. Now these are safeguard tags. Now when we built the model, we didn't have information about a lot of the instruments, but we did know their tag name from some of the documents. So this object here in sort of beige that's highlighted only has the basic info. We have its name, the fact that it's XSV 211-00102, and we use that as its code. But for some of the other information, we were able to get more details. So this second node here, it's also an instrument, but we have the fact that it's specifically a blowdown valve, and we have a load of other properties about it. So in terms of the barrier model, this model will function absolutely fine with the different levels of maturity, because all we need is the structure to aggregate status. We're looking to know if an impairment comes in against any of these tags, we want to assign a score and we want to aggregate it up. But from a user perspective, they might like to know the fact that it's on this PNID, or it has this calibration certificate. And when that information becomes available, we can add that in. So we can get value from the data model from day one with the absolute minimum of information. But as time goes on and we get more information, we're able to add that in without breaking the functionality of what was there before, but making it richer and more useful for the users. Okay, any questions from folks? Is there anything of that you want me to talk about a bit more, or want some more information on?
So I have a question here in the chat, Murray. It's, how do you keep a model up to date over the life of the asset?
Okay, that's a great question, because that is a big challenge. And just if we take this model as an example, you can see there's a lot of equipment related, and over time, some of these tag names might change or new ones might be added in. And in order for it to be value to the asset, it has to be accurate over time. The actual process of adding information to the model, to the Neo4j model, is extremely simple. The queries that you write are very short, but the bigger challenge is that validating that information before you put it into the model. So what we see in practice is that one runs a production and a test environment. So your production environment is your quality assured data model, and then you have a test environment where you test changes out before you deploy them into production. And we also use a model backup software called Liquibase, which allows us to keep backups of things so we could roll back if ever a change was made. Now, one thing that comes out of this is the fact that when you build a model the first time, it's kind of a one-way street, in that you create a load of build files and you get the thing up and running. But then over time, you make changes to that model such that those build files aren't relevant anymore. And what you actually need to do is to create a snapshot of that model so you could recreate it from a backup at any point in time. Then you've got the question of, how do you find changes? We've looked at different processes, like automatically applying changes when we see them in another system. But in many ways that creates the same number, if not more problems than it solves, because you have the issue of validating that the information that was input correctly in the first place. Is it information that applies now, for example? Sometimes information is added in advance of it being needed to a system. So say a project's coming online and information's added in like in preparation. You don't want that to go into your production digital twin just yet, because there is that equipment doesn't exist, say. So you need to have a manual step there where someone's overseeing the process of changes, and you need to apply some change management to it. We have a number of tools that allow you to audit the differences between the model and the source systems to make it a lot easier. So it's not a manual process. But I think the key point is that there needs to be a change management process around it in order to make sure that the information in the data model is quality and accurate all the time. Okay, great question. So any more questions?
So we have one from Schmack. If the runtime asset model is modified by admin users in production via custom UI, how do you then version control it with the master?
So if the changes are made to the production, then that becomes the master. And that's why you need backups. And we use, for example, Liquibase, so that you have the option of rolling back. Again, it's a discussion point, because there's always a tension between allowing users the flexibility to correct things that they see are wrong. Because if they can do that easily, then actually it improves the quality of the model. But then you have the trade-off with people making changes too quickly, or unauthorized changes, or changes where they don't realize the implications of things in the long run. There isn't a right answer to this. It's very much a company by company basis. I would err on the side of allowing the users the opportunity to fix things themselves, because if they stop trusting the model, they'll stop trusting the other systems that are using it. So for them, being able to correct things is really, really important. And it's almost better just to put the things in place to fix something quickly if it goes wrong, and allow people then to be able to change stuff quickly, than to make a very onerous process up front that makes changes very difficult, because it puts people off. And actually, they might decide it's quicker to keep their own spreadsheet again, or make their own system just for their needs, in which case you've lost the value of that single source of truth. So again, good question. I'm not sure I can give a really clear, this is how you must do it answer. But it is definitely something you should think about and engage your users in.
Amazing. And then we have another question from Pavel. So can the users interact with the model in other ways than just using Nail4j queries? Is there a possibility to develop a user interface that could help the users solve a particular problem? Example, modify an asset description or add a document.
Yes, and great question. And actually that really ties into the previous question, because some of the changes users might need to make might be frequent operations of a certain type. And in that case, you can easily put some quality assurance around it by making, just as you described, an automated process like an API that will let users easily add things or edit things that they need to, and it can put the checks around it to validate that information. So yes, it's definitely possible to do that. And in fact, we do that in things like the barriers. We have tools where users can edit or add things within a defined scope. So they can add tags into elements, they can edit the name of things, they can edit relationships. They can't go and create completely new objects of whatever type they want through this particular tool, but allows them to make the changes that they need to regularly within that scope. So yes, it's definitely possible, and it's a really good idea, I'd say, as well, to do it.
Amazing. And then finally from Jamel, will it be right to say that the scalability of this system is unlimited?
Yes, to all intents and purposes, that's correct. the only thing it takes is disk space and RAM when you come to run it, and they're cheap problems to solve. Neo4j is an enterprise class system. You can run it on a single server, but it also supports multiple servers. Is it called sharding? But you can run it across distributed hosts as well, and the models can get extremely large. It performs very well. It's in enterprise tested. It's used by all kinds of people like the FBI and others to model very large problems and run analysis against them. So yes, it's for all the problems we've come across and are probably ever likely to come across, this is more than capable of handling those. Good question.
Amazing.
So,
yeah, I think that's the end of our questions. Fantastic. Thank you, everybody.
Great. Well, thanks very much, guys. I hope that was useful. And as ever, if you would like any more information, please feel free to contact me directly. And if you have any ideas for other webinars as well, please let me know and we'll get them penciled in.